Right, perfect. Thank you, Ryan. Thank you, everyone, for taking some time out of your day to meet with us today. We're really excited to be here today. Just by way of quick introduction, my name is Greg Olson. I'm the Senior Manager of Education and Sales Enablement here at NewMetric. And I'm excited to be here and to be talking with you all today about our presentation here with the City of Charlotte. So really quickly, just to run through some high-level agenda items. General flow of the presentation that we're going to go through today. We'll start with just some introductions. We're actually then going to dive in and take a look at the data background that's been powering these capital project examples. And then Corey's going to walk us through some example projects. And then we'll have some time reserved at the end there for questions and answers. So if you've got questions as we go through the presentation today, invite you to hop in the chat window and drop your questions in there. We'll be keeping an eye on those as we go through the presentation. We should have plenty of time at the end to wrap up and make sure that we get all those questions addressed. But again, just hop in the chat window and drop those in there, and we'll circle back and get those all responded to before we wrap up. I wanted to introduce you all to Corey Watt, who's going to be our presenter today. Corey is the senior engineer, or a senior engineer with the Charlotte Department of Transportation in Charlotte, North Carolina. We were lucky enough to meet with Corey last October when we were in Charlotte for the AASHTO Safety User Experience Advisory Committee meeting. Charlotte was a great place to visit, great city. While we were out there, Corey shared this presentation with us. And it was such a great presentation. We all really enjoyed it that we immediately thought that we needed to invite Corey out here to share this information with all of you. So Corey, thank you so much for taking the time to meet with us today. And I'll go ahead and hand the time over to you for your presentation.
Awesome. Thanks, Greg. Appreciate the opportunity to present. Let me make sure, let me get this sharing. There we go. Hopefully everybody can see that. We're good.
Yep.
Cool. Okay, awesome. So like Greg said, just a little bit about me. I'm going to be talking about how we at the City of Charlotte here use crash data in our capital project decision-making process. Get this thing going. There we go. So this is kind of what I'm going to hit on, just a little bit about me and CDOT here, some of the functions that we utilize within our section when we're dealing with capital projects, from AASHTO safety-ware. I promised Danny and Greg I would call it AASHTO-ware today. Just as an FYI, we call it NewMetric here at Charlotte. So if I say NewMetric, I'm going to do my best to say AASHTO-ware, but if I say NewMetric, just know I'm referring to the same software. Like Greg said, so I'm a senior engineer here in the Planning and Design Division with the Charlotte Department of Transportation. My team primarily works on the development and implementation of your large-scale projects that are a part of our capital investment program here at the city. And just a little bit of background on CDOT. So and this will kind of highlight why we enjoy this software. So the way CDOT's structured, we're actually in the planning and design division is actually in a separate division than our traffic safety folks. So in the past, if we're working on a capital project, our team would reach out to traffic safety, kind of lay out a proposed scope for a project. One of their staff members would have to, search through their crash database, put together a report of what they thought we were looking for, and then provide that to a project manager in my division, my section. You'd have to read through it, try to summarize anything that you thought was relevant or analyze any trends, kind of by hand, to be honest. As you can imagine, that's a lot of effort to go through, which is fine on your larger scale capital projects. That's built into the planning process, but it's less likely to, kind of what we were finding was it was less likely to occur on something like a spot improvement project or a bicycle pavement retrofit, some of your smaller scale projects that we see in our section. We see a wide variety of projects, and I've got a couple of examples that I'm going to go through that kind of span the scope or the spectrum of municipal projects. They come from a variety of sources. So whether it's our traffic safety folks providing it to us, from our planners, from our partners here at the city, with transit, our transit department is separate, making improvements with them, or if it's coming from something land development related, as developers are redeveloping just about every block in the city right now. Kind of what we found is that using AASHTO has really made our crash data more accessible to everyone in the department, the way that we're set up, which in turn has made it easier to integrate, into our project development and our decision making. So real fast, I just want to hit on I'm going to try to keep it as simple as possible, and just run through a little bit of information before I jump into the examples. But this is kind of what we primarily find ourselves. This is just based on a poll of some of the other project managers in my section, in terms of what our popular features are that we see ourselves using time and time again. Primarily crash query, jump in there, can put down a shape, a polygon filter, a circle filter, to come up with, if we're going to do a spot study, or we have a project plan at an intersection, quick and easy. We find ourselves looking at crash types, crash severities, filters like, are there pedestrians and cyclists involved? For some of these projects that I'm going to hit on are corridor projects. So, we're looking at crashes, crash summary along the corridor. And then one that I just recently started using myself, the comparison tool. And I'll have an example of how we've used that actually last week, as part of a public engagement effort with a neighborhood, for one of these projects. And then we also utilize the safety analysis piece from the software suite. Primarily, I don't necessarily use it myself, but I ask our traffic safety folks to use it for me, and it's made their job much easier. I don't want to speak too much for them. I think our traffic safety manager may be on this webinar, so if there's anything specific that kind of gets into her realm, I can address that after. But yeah, just the crash modification factors and cost benefit ratios that are built into the safety analysis tools. We've had great success using those to inform some of our capital project decisions. So what kind of project types do we see, do we typically do here in the design section at CDOT? We work through a large spectrum of projects, from intersection redesign, street conversions. Street lighting has become a huge issue with our city council and with our residents here. Pavement retrofits, so trying to retrofit our existing pavement out there for pedestrian and bicycle accessibility, trying to make everything a little bit safer for all users. Streetscapes, so we're doing a lot of large scale streetscapes that involve huge pedestrian and bicycle investments as well. And then just standalone pedestrian and bicycle projects like adding sidewalks or adding separated bike lanes or shared use paths. And we have at CDOT, we have a complete streets policy. So all of our capital projects circle back to safety as for all users is a huge part of what we do and what drives our decisions here. So with that, I'll jump into some examples, some kind of case studies of recent projects that we've utilized the software to kind of inform some specific design inputs and decisions that we've made. So the first one I'm going to talk about is an example of a major intersection redesign. It's the intersection of Eastway Drive and Shamrock Drive here in Charlotte. see if I can get this laser going. So it's a heavily skewed 5-leg intersection. So this is Eastway Drive that runs north to south. It's a major thoroughfare. It also is maintained by the North Carolina Department of Transportation. So just another layer to this complex intersection. This that runs east to west here. This is Shamrock Drive. This is a city maintained street. And then we have this 5th leg over here. This is Frontenac Avenue, which is a right in, right out, stop controlled leg. So it's not under the control of this signal. And also for fun, there's also a fire station right here that's pretty busy and has control, the ability to control this intersection so that they can get in and out of their fire station here and get wherever they need to go. And then you can also see just from the aerial, this is, you know, kind of your typical older designed intersection here, relatively hostile to bikes and pedestrians. There's no cyclist facilities. We have right turn slip lanes that can free flow. We have these long crosswalks. Some sections, you know, some crosswalks aren't marked. Out here, we have issues with pedestrians because there's no crosswalk here. So they'll try to frogger their way across 6 lanes of traffic back here. So this is a huge redesign project that we have going on. We worked with a consultant here to kind of perform a traffic analysis and to evaluate some alternative designs. And we were able to use AASHTO as part of that process. You know, it was very easy to kind of quickly and easily summarize crash types and the severities that we saw at the intersection here. Because, you know, we're primarily, when we're going to do this redesign, trying to look for specific trends or any safety trends that we can address, specific crash types, severity, in addition to just the congestion mitigation and operational aspects of the intersection as well. And so what we found when we got all of this crash data in one place and we're able to sort it by type and by severity and read some of the crash narratives through AASHTO, kind of what we found was that rear end and left turn crashes accounted for about 67% of the total crashes at the intersection. And using some of the more advanced filters and by kind of digging deeper into the crash narratives and diagrams that we've integrated into AASHTO, we were able to highlight pretty easily and quickly 3 big conclusions to work into our design, into our alternatives. So the first one that we found was that the eastbound left turns here from Shamrock onto Eastway Drive, we were seeing a lot of crashes that were related to that movement because it is a skewed intersection. You know, this is a very strange movement to make. And it's tough to see in this aerial, but intersection is actually in the middle of a horizontal curve along Shamrock Drive. So the amount of offset that's going on here at this intersection made sight distance kind of difficult to judge. So a lot of the crash narratives hit on people that thought they may have had a chance to get across, but ultimately they didn't really have time to see and perceive an adequate gap to get across there. The second thing that we found were U-turns from southbound Eastway. We had a lot of folks that were trying to make this U-turn for whatever reason. And it actually was not prohibited at the time that we did this study. So we had a high percentage of those crashes and kind of realized, hey, we need to prohibit U-turns on whatever design alternative we decide to go with here. And then finally, the third kind of key conclusion that we drew from looking at the data, this is a Shell gas station convenience store right here. You can see they have one driveway located on Shamrock Drive. We have another driveway located on Eastway Drive. This driveway is actually in the intersection, but doesn't have any type of control or movement restriction on it. So you had what we were seeing from these crash reports and from being able to aggregate all this data in one place is that drivers were, for whatever reason, they were trying to make a left out of here. They were making rights, but they were unsure of which movement was going to be coming through the intersection to conflict with them. So they were having difficulty judging gaps if they could get out here. If you're looking closely, you can see that this parking lot does connect and there's another driveway down here. So kind of asking the question of why are folks choosing to make this choice here rather than just go down and make a safer choice down there. So relocating or closing or altering the operations here at this driveway was kind of one of our key conclusions as well. And so, we evaluated a couple of different alternatives. This on the screen right here on the slide is what was chosen as the preferred alternative. But during that evaluation process, part of the ranking criteria that we looked at was how each alternative specifically addressed the three concerns that came out of the crash analysis. Some specific alternatives, we had median U-turn as an alternative, quadrant left, which is what you're seeing on the screen. And then we also looked at an alternative that realigned the intersection into a more traditional layout. And you can see, your eastbound, the first movement I talked about, the eastbound left turns from Shamrock Drive. So two of our alternatives, the median U-turn and the quad left alternatives, they just completely eliminated that movement. Right? Like the safest way to prevent someone from a crash from a specific movement is to just not allow that movement physically. And additionally, the realigned alternative, because it kind of removes some of the curvature that was going on, was expected to heavily improve sight distance for folks that were trying to make that left turn. The second one that we had, the southbound U-turns on Eastway Drive. And then also part of that was the left turns, folks trying to turn left into this Frontenac Avenue, which was a prohibited movement because it's this little pork chop island, was trying to prohibit people from doing that, but it wasn't the clearest the way that the intersection was designed. So the median U-turn and the quad left just removed left turn lanes from southbound Eastway Drive and relocated those left turns to other signals and other movements. And then the realigned alternative also relocated, took the opportunity while we're realigning this, let's just remove Frontenac Avenue from the intersection and remove all the conflicts that were associated with that. And then finally, the driveway here, the Shell gas station, this quadrant over here, the Shell gas station driveway, the realigned alternative was able to create enough space to completely get it out of the intersection, while the quad left and the median U-turn, we're going to reconstruct the driveway to physically prohibit those left turns that were causing folks, some confusion. So using this concrete mono island here to physically limit that ability to take a left and make it a right in, right out situation. And so ultimately, this project is moving forward in design with this alternative as the chosen alternative, based a lot, obviously there's a lot of operational characteristics and things that we're working through that go into selecting an ultimate intersection concept. But you can see that safety, what we were able to glean from our crash data, played a huge part in that. So the next project that I've got here is an example of a street conversion that we've recently kicked off. This is on Matheson Avenue here in the city. So to kind of set the scene for you, this is the Shamrock Drive, Eastway Drive intersection right here that I just talked about. We have a complete street project on Shamrock Drive here that's going to be a major east-west connection for cyclists and pedestrians, as well as vehicles. We have a couple of other bicycle projects, and I'm going to talk about this protected intersection at the end of my presentation here. But we needed to come up with a way to kind of connect everything that we were investing in here in terms of bicycle infrastructure to what we were investing over here. And so what we looked at, or what the first kind of concept that came to light to do this, was this section of Matheson Avenue was up for resurfacing. And so obviously when we have a, you know, whenever you're looking at resurfacing a street conversions are a popular alternative to look at for when you're doing that. Here, the city of Charlotte, we have a committee that looks at all of our resurfacing efforts for the next couple of years, and then kind of tries to capitalize on that to get bike and pedestrian infrastructure on the ground. And this intersection right here, so this is another major thoroughfare in the city called the Plaza. This intersection has been a nightmare for the city for a long time, just operationally. It is a level of service F type intersection already. We've had a bunch of studies to try to see what the best way forward to redesign this is. So we had some serious safety versus capacity trade-offs that we would have to consider as part of this process. And you can see here, this is the intersection that I just talked about. So able to quickly drop this geofilter in here and see, you know, you have some that you'd have to sort out that are on private property, but able to get a quick summary of what's going on at the intersection there, just to kind of set the stage for the road diet or the street conversion planning process. So this is part of the analysis that was conducted as part of the concept development. Easy to drop a filter here and capture just what's going on along the corridor, and then very quickly able to see, you know, we have a significant percentage of angle crashes, rear end slow and stop, and side swipe same direction, which street conversion. So this is a 4-lane thoroughfare, 2 travel lanes each direction. The proposed typical section is to go down to bicycle facilities on both sides, 1 travel lane each direction, and a 2-way left turn lane down the middle. And so it's incredibly dense. There's a lot of driveways. This is a single family residential land use along most of this corridor. So this just further kind of supported our idea for the street conversion, because, you know, street conversions typically they've been shown to reduce angle crashes, to reduce those rear ends associated with left turns, and then side swipe as folks are trying to get around turning and slowing traffic, side swiping other vehicles. And then another kind of benefit to this, so what we're using this as a metric to kind of help us determine if a street conversion is successful or not, because a lot of while we're, you know, proposing a street conversion is to increase safety. And actually, I had a neighborhood meeting with these folks that live out here last week, and we specifically discussed this project, but I was able to use the compare tool and AASHTO Safetyware to kind of, we have 2 other street conversions that are similar scope and similar style conversion in nearby in the network here, that have been down on the ground for a year or 2 now. So we have just enough to kind of get a little bit of before and after data, which took me about 10 minutes to get a slide together for both of those projects that summarized crash history before and after each of those road conversions went into effect. So it was a really easy tool to kind of sell the neighborhood on why this why this was going to respond to their safety concerns along the corridor. And just some major insights that we drew from that corridor analysis, from getting all of that data in one place. At one of the intersections, there was actually a pedestrian involved crash where they were struck by a vehicle that didn't see them because of the way that the crossing was laid out. And so to address that, this project concept that we're developing includes tighter curb radii, marked crosswalk, RRFBs, pedestrian refuges at this intersection where that crash occurred. And we actually just decided, instead of an RRFB, to go up to a pedestrian hybrid beacon there to respond to some of the concerns the neighborhood had. We also saw, and I kind of hit on this a minute ago, but our common crash types are your left turn and driveway density related crash types. There's a driveway density of about 77 driveways in a 1 mile stretch along this corridor. So the project includes a two-way left turn lane to help mitigate some of those crashes. And then we also saw there was a larger intersection here. You can kind of see it on the aerial. This Clemson Avenue connects down here to the plaza. So you see a lot of traffic along here. It's currently a movement restricted intersection. So it's not it's not signalized. Clemson Avenue is a right in, right out. And so we had a heavy concentration of crashes that were primarily related to non-compliance with the right turn only restriction. So we just decided to completely signalize that intersection to address some of those crashes, as well as the operational limitations that we were seeing there of restricting movements. So the next one that I want to talk about, so streetlight installations, specifically a corridor here in Charlotte called W.T. Harris Boulevard. So street lighting here in the city of Charlotte, like I said, it's a huge issue. It's something that the public is very in tune to and very actively engaged about with our city council folks here. And we have a challenge here in Charlotte where a lot of our major thoroughfares within the city are actually state maintained thoroughfares. And so lighting them has always been a challenge because the state, kind of relies on the city to take care of the thoroughfares within our jurisdiction. And so what we found is that a lot of our major thoroughfares were unlit. And this particular project, so it's about an 8 mile long corridor, major thoroughfare. It's Charlotte's kind of laid out in a very rough hub and spoke type design. So this is one of our further out from the city core, one of our loop roads that facilitates that loop movement around the urban core of the city. ADT kind of varied widely, but just to give you a range, is 25,000 to 40,000 vehicles per day along this corridor. And we didn't have, this is back in probably 2000, 2001, right as street lighting was picking up. We didn't necessarily have a source of funding within the city to fund a large project like this. This is about $1 million installation by the time that you work with our energy supplier here, that Duke Energy, that does all of our street lighting. And then by the time, because this is such a major thoroughfare, we're have to use breakaway streetlights, decorative streetlights, which are substantially more expensive than just your wood pole. So this was a large scale project. So we sought some alternative funding sources via our MPO, which is the CRTPO there. But what we found was that most of their funding application was geared primarily towards roadway and bike ped infrastructure projects. This was more functioning as a utility project because it was just, installing conduit or conductor and lights along the right of way. So their scoring criteria were primarily revolved around safety, which were crashes, a formula of crashes and ADT, congestion, so your volume to capacity ratio at various intersections or along the corridor. And then they also use cost effectiveness, which was basically they summed up the two previous scores and then divided that by your cost estimate to kind of give you like a benefit to cost ratio. So we really struggled while we did this grant application, on how we were going to quantify the benefits of a project like this when it didn't necessarily fit into the bin that they were prescribing. So we actually, this was when we were relatively new to AASHTO to New Metric. We had just brought it online and rolled it out to the wider group from just the traffic safety folks. So this is actually the first time that I was involved with it. But this is what we kind of used to quantify the benefits of a large scale street lighting project. So we used Crash Query. Kind of the insights that we got, we found there were about 1,000 crashes in the last 5 years along the corridor. 243 of those were serious injury or fatality crashes. Excuse me, not just, they were any type of injury or fatality. And 35% of those occurred at night, which was pretty eye-opening for some folks here at CDOT, just to kind of, previously we didn't have that data as granular and as easy to access as it is now. So just to be able to quickly and easily summarize crashes like that and say, yes, we know we need street lighting out there, but now we kind of have some numbers that support that. And then our traffic safety folks, I was told by our traffic safety manager that she had only done a handful of cost benefit analysis while she worked here at CDOT, just because of the amount of time that it took to work through the process. So I asked her to do one for this using the tool that was the safety analysis tool that was built into New Metric. I think she did it in a couple of hours using crash modification factors provided by NCDOT, so our state agency here. And what that analysis found was that by adding lighting along this corridor, we were expecting to reduce crashes overall by 48%. And that let us kind of quantify our own B2C ratio here of 17.7. And then the tool kind of gave us just an estimated annual public safety savings of $3 million to associate with that reduced, those reduced crashes and all that, the cost of injuries and fatalities and property damage. That let us tell a story. We were actually able to attach this analysis as a addendum to our grant application to kind of better tell our story. And when it was all said and done, we actually had the second highest score of submitted projects for this year, and we're able to secure about $1 million in funding to actually get this project on the ground. And then this is my last one that I wanted to talk about, kind of lumped in our pavement retrofits and head and bike projects into one case study. So this is North Davidson Street and Jordan Place. Protected intersection. So just to kind of set the stage and give a little context. So this is Matheson Avenue. This is where the street conversion that I talked about earlier ties in. So this is North Davidson Street, a major thoroughfare that runs through the city here. And then this little stub is Jordan Place right here. This is an overpass. Matheson Avenue goes above grade to get over. This is a rail yard over here. But just kind of take a look at this aerial. So this aerial is from 2010. So take a look kind of in this area, mental image of what it looks like in 2010. This is what it looks like this year last year in 2022. So this is an area that was in what we call our NODA neighborhood here, North Davidson. So it's a heavily redeveloping area. It used to primarily just be industrial and manufacturing land uses related to the rail yard right there. But now it's redeveloping with young professionals and young families that are moving in here. As you've got breweries, apartments, townhomes, overall just density is going up drastically in this area. And with that, you also have more people that are out walking and biking. There's also a light rail station right here. The light rail alignment here runs, it connects NODA to Uptown, which is what other folks would consider their downtown business area. So that's our business district down Page South here. And then on the other side of Uptown is another similar neighborhood to NODA called South End. It's another heavily redeveloped area that's very active, but folks move back and forth along the light rail between those neighborhoods. There's also a rail trail that runs for most of this alignment as well. And then this direction on the light rail goes to our University of North Carolina Charlotte campus further out to the east. So this is a huge transit connection within the city. We also have what we call the Cross Charlotte Trail. So it's a 30+ mile series of greenways and on-street bike facilities that's an all ages and all abilities type project. It runs essentially south to north across the entire city. And it comes through this intersection with North Davidson and Jordan Place. That's where we're transitioning it above grade to get it over this rail yard and the railroad tracks so that it can continue on the other side of the tracks. So we knew this intersection here, you know, if we're bringing all this bicycle traffic through here, all this pedestrian traffic related to redevelopment, we knew that this needed some redesign to make it actually all ages and all abilities accessible to support the trail crossing through here. It was this intersection, you'll see on the next slide, but it was with the industrial use here, it was primarily intended to support large trucks that were coming in and out of the rail yard and all of the industrial sites that used to exist out here. So it's some of the corner radii are pretty large. So we looked at Crash Query. What was it telling us? So you can see just real fast how much speed do you think a vehicle would be carrying as it was navigating these turns. This is also a decent grade right here coming down, and then just a wide NASCAR style turn here that folks can hit pretty quickly. So we were able to do an intersection query and look at our, use our integrated kind of the crash narratives, how they're integrated into the software. And we found this, so I'll read it to you and kind of sketch it out here. But so the driver said they were traveling southwest on North Davidson. They made a left turn onto Jordan Place, and they didn't see a cyclist that was on the roadway in Jordan Place here at this stop bar. So the cyclist essentially was sitting here. They had a red light. They were sitting at the stop site, the stop bar right here, waiting to continue through the intersection. Someone came carrying enough speed here, cut this corner in tight. The cyclist saw it coming and was doing everything they could to get out of the way. The vehicle hit them. Luckily, it was only a minor injury and not a fatality, but it very well could have been a fatality. And we saw that trend throughout this intersection. This was another one here where a cyclist was stopped at the stop bar and got rear-ended by somebody, by a vehicle. So we noticed that, hey, cyclists we already have an issue with high vehicle speeds because of the corner radius at this intersection, and we're seeing cyclists that are basically being hung out to dry, vulnerable road users out here that are being involved in crashes. And most of our PDO, our property damage crashes related to vehicles, almost all of them involve high vehicle turning speeds. And so what was our conclusion from that? This needed to be kind of a premier protected intersection here in the city. And so that is what it was ultimately designed as. If you jump into aerials and you take a look at this now, it's implemented via a paint and post style temporary setup while we wait for the capital project to come through here later this year and actually construct the protected areas for cyclists and pedestrians to queue at. We're adjusting the radii here using concrete mono islands to slow those vehicle turning speeds, and also giving your cyclists and your pedestrians a little bit more hardened buffer to sit behind as they enter a separated cycle track here to continue along the Cross Charlotte Trail. And with that, that's the last case study that I've got. I think we've got time for some questions, or if you guys had anything come through the chat there.
One moment. Oh, perfect. Audio on yours. Sorry about that. Having a little audio problem here. Thank you, Corey. Fantastic presentation. Great information as always. Appreciate you running through and walking us through that information. We have had a couple questions come through here. So if you're okay, I'll just kind of fire some of those over to you really quick. The first question I wanted to address, and I know that this is something that has come up. I've heard Angela talk about this over in Charlotte as well a little bit, but you mentioned in one of your projects that you were meeting with the locals and kind of discussing the impact of that project. When you were having those conversations with them, did you create specific reports that you shared with them, or was it more you accessing that information and then sharing it with them more informally?
Yeah, so it was the more the second one. So yeah, Angela, we leave her to kind of deal with the more in-depth analysis of traffic safety. But the kind of the initial problem that we had, so we had these 2 street conversions that we worked on. And when you just looked at, one of them had only been online for a couple of months before I had to go talk to the neighborhood. So we didn't have a ton of, when you look at percentages with crashes, all it takes in that amount of time is 1 or 2 crashes, minor crashes, to kind of skew your data to the point where we understand that as transportation professionals, but the public, all they see is, oh, your crashes went up 5% after this. Well, no, what happened is there was a crash, at an intersection not even related to this, but it's on the corridor, so it affects the crash numbers. What we did was just calculate crash rate using the software, so able to just quickly do a before and after, say, hey, this was the ADT of the road. This is how long our corridor was. This was the number of crashes 5 years prior to the street conversion. This is the number of crashes we've had after implementation, and just kind of normalize that data where you have 5 years competing against a couple of months or a year of data. But no, we've never, I kind of see that as our role is to digest that information and then spit it out to something that the public could easily understand. So it ended up being distilled down to like 3 bullets on a slide.
Perfect. No, that's great. And actually that hits on, there was kind of a part B to that question, which was, if so, how did they understand or react to that information? And I think you kind of explaining that accessing that information and digesting that information happens kind of behind the scenes. And then when you're presenting that, it's a little bit more polished, a little bit more, user friendly from someone who doesn't live in that space necessarily, right? So
right,
awesome. Yep. Thanks for Couple more questions that have come through. We've had some great questions coming through. So if you have more questions, by the way, keep dropping those in the chat. We are keeping an eye on that. So next question we have here is, did you have CMFs already available on Numetric after you selected those crashes? Or essentially, does the software help you identify those CMFs when you're doing that benefit cost calculation?
So unfortunately, I can't answer that because I didn't perform that work. So our traffic safety manager did that analysis and brought in the CMFs herself. So she did all of the, is this an appropriate one? Like I said, I do know the feedback that she gave me is that normally it would take her a substantial amount of time to perform that analysis, and it didn't using this software. So I think she said I think I asked her on a Monday if she could do it, and our grant application was due on Wednesday. So,
yeah, so I am here, Corey.
Yeah,
okay. I'm here.
We actually do have Angela here. So Perfect. Angela, take it away. Thank you.
In the flesh, so to speak. Yeah, so we actually have a standard list of CMFs that NCDOT has approved. And so we input those into safety analysis with the help of the folks over at AASHTO Wear Safety. And see, I didn't slip up. Danny, you should be proud of me. The benefit to doing the NCDOT CMFs was that our local NCDOT traffic safety unit person who created the list used to run the CMF clearinghouse. So I feel incredibly confident in his choice of CMFs for a given treatment.
Thank you, Angela, for being willing to be drafted into our webinar. I appreciate that. And thanks, Corey, for helping out with that as well. So we did have one question as well, kind of a follow-up to that came in as you were answering. It said, is NCDOT's CMF clearinghouse publicly available? I'm not sure on that one necessarily. And Angela, I don't know if you're still unmuted and available to answer. Looks like we need to allow you to unmute here really quick. Hold on. Oh, one moment here. Okay.
So yes, the NCDOT list is publicly available on their NCDOT Connect website. And I will find the link and shoot it over to Greg so he can shoot it out to the webinar participants.
Perfect. Thank you, Angela. And thanks again for being so willing to hop in and help out here. So one more question that's been kind of coming through that's related to these benefit cost calculations. This question is the benefit cost ratio calculated using observed crashes, or does it include predicted crashes based on the HSM methods? And if you don't mind, I'll kind of take a swing on this one because there's kind of two parts to this response. Currently, the way that the applications are set up and configured, we are using observational data. So it's strictly using that historical crash data that we have available. However, we are currently working on some software improvements that will allow the ability to include predicted values in those benefit cost calculations as well. So current state, we're using historical that observational data. And shortly here, we're working on adding the ability to include those predicted values mentioned in the HSM. So great question. That's a good question. Yeah, so another question that did come through, Corey, and this came up as you were talking about those redesigning your street conversions. How do you decide to add bike lanes if there's no existing bicycle data available? Do you just make the decision to build the lane based on the Charlotte Complete Street Plan, or is there other data that you're using to help kind of drive those decisions?
Yeah, so kind of our philosophy here at CDOT is that if we're going to do a street conversion, the primary reason that we're doing it is to reallocate unused vehicle space to other users. It doesn't necessarily have to be a bike lane going in there. For this particular project, we were trying to connect to high quality bicycle facilities. And so that was where the buffered bicycle lanes ultimately came from. But yeah, we do have other, our planners are hard at work on our future bicycle network and what that looks like right now. We're in the middle of a huge strategic mobility plan push. So we have a 2040 plan that's trying to move 50% of all single occupancy vehicle trips to something other than a single occupancy vehicle. So building out our bike network through street conversions like that is one of the ways that we're going about that.
Great. Awesome. Thank you. Thank you. Let me check in really quick and see if we have any more.
Yeah, I will just, just to kind of circle back or add a little bit of a clarifier to that. So from looking at some of our crash data and along that corridor, kind of one of the other key pieces that I didn't have on the slide was crossing distance was an issue. Folks trying to get, because those are 4 12-foot travel lanes. So pedestrians trying to cross almost 50 feet of a major thoroughfare. So that also factored into kind of using the bike lane, buffered bike lane installation, because that would reduce the number of lanes that have to be crossed by pedestrians. So that was part of what played into that.
No, that's great. Thank you for sharing that kind of additional insight there as well. One last question that's come through, and then I think we'll go ahead and wrap up. The question was specifically around ownership and responsibility. So the first example that you were showing with, I believe it was the plaza in Eastway, it was a split responsibility, right, between NCDOT and the city of Charlotte. Just one question that came up around ownership and maintenance of that intersection. On state routes, who is the responsible owner for maintaining those lights and traffic signals? So kind of more of a kind of back end responsibility kind of question, but we figured we'd address that one before we wrap up as well. So
yeah, when you're working on a project, so we actually, so CDOT within the city limits operates all of the traffic signals, regardless of if they're an NCDOT owned signal. But maintenance responsibilities are split up between the city and NCDOT. So everything is always a partnership with them in terms of how those are split up. Yeah.
Sure. Actually, signal maintenance and installation is both ours.
There you go. Thanks, Angela.
No problem.
I couldn't remember if it was 100% maintenance on us or what, but Angela also used to work in that section as well. So thank you.
Well, you've officially been on a webinar with Greg because you've slightly misspoken and Angela has swooped in to set the record straight. So yeah. I appreciate Angela's willingness to always hop in and provide those clarifying comments. So thank you for that.
And they all need to know that Shamrock Drive is your favorite street in Charlotte, Greg.
It is. It is. There's a special place in my heart for Shamrock. So. Glancing up at the clock here, looks like we're just about coming up on time, and we haven't had any more questions rolling in through the chat. So I think we'll go ahead and wrap this up. Corey, thank you again for taking the time out of your day to share this wonderful information with us and to kind of give us a little insight into how y'all are making your roads safer over in the city of Charlotte. Thank you all for taking the time as well to meet with us today. We have recorded this webinar as well, and we will be sending a copy of that recording out to everyone who registered, and we'll also be posting that on our website as well. So Thank you all so much. Hope you have a great day and stay safe. Thanks, everyone.
Thank you.